All right, so today's notes are on functions and relations, or relations and functions, and our content objective is to identify functions, use function notation, and determine domain and range. Our language objective is to use the correct notation and terminology to describe functions and their characteristics. So we're going to start with defining a relation. So a relation is a set of inputs, of input and output values. There's several ways we can represent relations. So I'll make a list. Can be represented as, and then there's several that you've probably heard of before. So ordered pairs. These are just coordinate points, x, y. So if it's just a bunch of points together, they can just list all the points as one, and that would be a relation. You can also have tables. So a table with inputs on one side, outputs on the other. So it'd be like a T-chart, X, Y, and they have the list of numbers that go together. You could have a graph. You guys have seen plenty of graphs of relations before. So just anything that's on an XY grid or coordinate plane would be a relation. And then last but not least, you may not have seen this one before, but a mapping. I'll do this up here to save room. So a mapping diagram. So the way this might work is you have your input values in one circle. So we'll make up 3 or -3, 3, 4. They'd be in an oval there, and then you have output over here. And we'll make these up as well, 4, 1, 3. They're in their own oval, and this connects the input values to the output values. So -3, 4 would be your coordinate point, or 3, 1, or 4, -1s. They don't always go directly across. They can go up and down to other ones. So you could have 4, 1, 4, 3. Any of those could be coordinate points for a relation. So we're going to delve into relations a bit more, but first, before I get into functions or functions as relations, we're going to talk about the domain. So the domain is the set of inputs, or as we will often use for a variable for inputs, x coordinates. So we will not always use x to represent our inputs, but we often do. So I'm putting that as a reminder. Your domain is usually your x values or the set of inputs. Your range is the set of outputs, or as we'll often see, the y coordinates, the y values. And the reason I bring up domain and range now, so domain is the x, range is the y, you may have seen that before, but the reason that's important for today's lesson is because a function, the specific definition we have for a function is a relation in which each element of the domain corresponds with exactly one element of the range. So more simply put, our x values do not repeat. So your x values for a function do not repeat. A relation can be anything on a coordinate plane. You can have x's repeating as many times as you want. You can have whatever you want as long as it's just x and y. So relation is any sort of x and y combination or input-output combination. That's a relation. Whereas a function is specifically, it's a type of relation, so it's a subset or within a relation. All functions are relations, not all relations are functions. But a function is a more narrow or more specific definition in that x values do not repeat. So x's don't go, the same x can't be used for more than one y. You can't plug in one x value and suddenly get two y values. That wouldn't be a function. It could be a relation, but it would not be a function. So our x values do not repeat for a function. The next thing I want to do is show you some examples of functions versus not functions, or just more general relations. So I'm going to flip the page so I have some room for those examples. So I'm going to make a quick table. First side will be functions, and then the second side will be not functions, or not a function. I'm going to give you a couple examples. So we'll start with a mapping. So an input, output, we'll do -3, 0, 4 in our first circle, and then 2, 1, or -1, 7 in our second oval. And we could have this, we can have these cross over. But as you can see, each x value only has one arrow coming out of it. On the other hand, if it were not a function, we'd have our input and output still. And we'll say we have 2, 3, 4, 6. So we'll give ourselves one extra one here. And then -1, or -3, -1, 3, 6. So again, we'll have 4 values here. But this time, we'll have 2 go to -3, but then we'll also have it go to -1. And then we'll have this one go to -1, this one go to 3, and this one go to 6. So here, this one's not a function because this 2 right here that I'm circling in green has 2 arrows jutting out of it, which means that x is used twice, or that x is repeating, so that does not work. You could also see a set of ordered pairs, so I'll make the small little ones, say we have -7, 14, 9, 7, and 7, 14. Oh, sorry, 8, 14. No, that's fine. 7, 14. So again, if I look at each of the values, none of my x values repeat. See, the y's can repeat. That's totally fine for functions. You can have y values pop up more than once. That's not an issue. But none of the x's repeat. So that's what's more important here. However, if we have a non-function example, we'll have 4, 1, 8, 6, and then I'll skip to 4, -1. So here, this one's not a function because as you see, the x value 4 pops up twice in that list, so that cannot work. The last one, we'll do a graph here, so bear with me while I make a quick x, y axis. I'll just draw an absolute value function. We'll learn about these more later in the year. But this is a function because as I skim along the x-axis, there's no place where it pops up more than once. So I'll show you the non-example as well. We again have our x and y axes. This time we'll do a sideways parabola. This one does not work because if we look here, so for this x value, we can make up a number for it, say it's 2. So we can see that when x is 2, there are 2 places that we would, or 2 y values that we would get for this x value. So this will make up a number and say it's 2. So at 2, when x is 2, we could have this y value or this y value. So we listed these as coordinate points, we'd have repeating x values, and that doesn't work. So what I just showed you an example of is another term that we're going to have as part of our vocabulary for today. It's called the vertical line test. And that's what we just did with our graphs. So we did the vertical line test. Here, you see I can draw vertical lines, and there's no place I could draw a vertical line where it crosses the graph more than once. So as long as you can draw a vertical line anywhere and it doesn't cross your graph more than once, it is a function. So if a vertical line passes through more than one point, on the graph of a relation, then it is not a function. So as I showed you in this example here, if you can draw a vertical line and it passes through more than one point, it's not a function because it would, that x value would repeat. So it is not a function. So that's our definition of a function, is the x value does not repeat. A relation, x values can repeat. It's just anything that relates x and y, or input and output. So I want to delve a little more into function stuff since this is going to be an emphasis throughout the year. So one important thing that we're going to deal with functions is function notation. So function notation looks something like this. I'm going to make up a function rule 3x plus 2. So this is our function rule. But this is what people are often less familiar with. We read this as f of x. So when you see something like this, they might sometimes use different letters, but it could be f of x or g of x or h of x. But the important thing is that there's some letter here and then your variable in here. And this is really similar to what you've probably seen before. So you might be used to seeing it written as y equals something, y equals 3x plus 2 in this case. So all this is doing is replacing the y with f of x. So that's all we've done here is switch out the y for f of x. And the reason we do that is because we can plug in values for x and see what we get out. So what I want to do for an example, say I asked you to find f of x equals 3x plus 2 when x equals 2. So what this notation allows us to do is say, okay, f of 2, so I'm plugging in 2 for x equals 3 times 2 plus 2. I solve that out, and then f of 2, 6 plus 2 is 8. So f of 2 is 8. So this allows us to say what we plugged in as our input and what we got as the output all in one math sentence rather than writing it as just having y equals 8. It tells you what your input was and what your output was all in the same math sentence. So then we can say, oh, our coordinate point is 2, 8. So that's why function notation is often used, because it allows you to see both those pieces of information at once. The last thing I want to talk about, so sorry, make sure you write down any questions you have at this point, but there's one more thing I want to talk about. I'm sorry, I'll let you copy that down real quick. But there's one more thing I want to talk about today, and that's domain and range and how we can write that and communicate that to other people. So I'm going to flip the page if you copied that down. But domain and range can be written in several different ways. So domain and range, I'm going to show you a few different ways that it ends up being written or can be written. So you can write it as a list. And this is often done if it is a set of points. So if you're given a list of coordinate points, so I'll give us a quick little list here, 2, 5, 7, 3, 9, 15. While I'm writing this, quick check, is this a function? Yes, none of the x values repeat. So here our domain could be written as just the list of x values. Usually I write it from least to greatest, so it would be 2, 7, 9. That would be our domain. Our range would just be the list of y values. Usually, again, I write it least to greatest, so I'd write 3, 5, 15. And that's our range. So you can write domain range just as a list of points, especially if that's how that's presented to you as a list of coordinate points. But you can also write it as intervals. And this is where our knowledge of inequalities that we just learned about will be helpful. So we can write this as intervals. So one example, this is usually done if we have a graph. So if we had a graph, bear with me here, I'm going to do a quick sketch. I'm going to say -1 and 1 is here. I'm going to do a starting point, so it's not one with an arrow and an ending point. So this is not arrows continuing on, these are designated stopping points. And this is important for writing domain and range because, as you know, domain is the x values, range is the y values. So here, our domain could be written as an interval. So this is why when we're looking at domain, we're only looking left and right because this is our x-axis. This is our y-axis. So domain, we're only looking left and right. As you can see, we started at -1 and we ended at 1. It's bounded between there if we look left to right because that's our starting point and that's our stopping point. So we can write it as a sandwich inequality, as I've been calling them. So again, they're filled in holes. So I can say -1 is less than x, which is less than or equal to 1. -1 is less than or equal to x, which is less than or equal to 1. And since those are the bounds, my domain is bounded by those points, I can write it as that interval. I can also write my range as an interval. So since it starts here at 0 and stops up here, I'll say at 3. I'm going to make up that number. So this is our top height. Our y can similarly be written as a bounded interval. So 0 is less than or equal to y, which is less than or equal to 3, because now we're only looking up or down. So how far did it go up or down? Started, lowest value was 0, highest value was 3. So that would be our interval. The last way we're going to write it can write as all real numbers. So if our graph is not bounded, so if we had, again, x, y coordinate plane, if we just had a graph that went forever, so it has arrows on either end, it just goes forever in both directions, then we'd write it as all real numbers. So our domain here, there's a few different ways you can write that. I'll show you a couple different ways that they write all real numbers. I prefer to write it as x includes the set, so it's like a weird half C, half E thing, and then a fancy R with 2 lines. So again, the range would be similar, but with y, so y includes the set of all real numbers. You could also write it as an interval, but from negative infinity to infinity. So infinity is like a sign, is like a sideways 8. So you could write it from negative infinity to infinity as well. That's another acceptable way to write it, but I prefer this way. So those are the 3 different ways we can write domain and range: as a list, as an interval, or as all real numbers. Make sure you write down any questions, comments, or concerns you have so we can go over these together in class.